I think. Hi there, I'm Samantha, and I'm here today in Re3D Austin headquarters in our research and development building. We're still working on getting HVAC, so if you know of someone in the trades, we'd welcome an introduction in this side of the house. But I'm honored today to have the opportunity to introduce my teammate Mitchell, who's sitting in our operations building. We'd love to give you a tour. Mitchell is our software engineer. He came to us after earning a bachelor's degree in computer science, as well as a minor in 3D printing for art and industry at Troy University. So we've been honored to have him. He's also has a wealth of experience from other contract work and additive manufacturing that we lean into, and really is the brains behind the Klipper main sale stack that our Gigabyte X2 customers use. Again, you are by no means obligated to have a Gigabyte or to be a Re3D customer to be part of this community. We're just looking forward to sharing our experiences in fused granular fabrication with yours and highlighting others in the ecosystem. So with that in mind, I'm going to go ahead and turn it over to Mitchell, who will share a little bit about his software engineering expertise today.
Awesome. Thank you, Samantha. Yeah, and thank you everyone for joining today. I'm going to go ahead and share my screen, slide deck. Okay. Right, yeah, so as the title suggests, we will be talking about Klipper today. We started using Klipper back in 2022 when the Gigabyte 4 and Gigabyte X2 was released. And so that has been our primary firmware since then. So we'll be going through a couple of things today. This by no means will be a comprehensive, demo of everything because one time, and also I want to make sure that people who haven't been exposed to this are still able to gain some knowledge. And so we'll be going over some of the background on the Klipper ecosystem. We'll be demoing Klipper commands from simple macros and input. We'll do some more complex examples. We'll go through things like API requests, shell commands, and for those that like to use Arduino, we'll have an example there as well where we can control an Arduino with Klipper. And after the demo, we'll go through some of our implementation examples, some of the things we've used, and some of these custom applications with Klipper, and then we'll do questions, of course. So this is a very simplified diagram of the Klipper ecosystem. So Klipper, when we say Klipper, that is referring to the firmware, which is on our microcontroller, our main board. Mainsail is our user interface. So that's everything you see from the front end. And Moonraker is sort of the in between. It is the application programming interface. So essentially, Klipper communicates with Moonraker, and then Moonraker communicates with Mainsail, and vice versa. So the conception of Klipper was that a main board could be connected to a single board computer, like a Raspberry Pi, and that single board computer could offload some of the processes from the main board, and so you can get much higher step rates than you previously would. And so that is the main reason for Klipper. And so the Moonraker and Mainsail aspects are more front end, and so that is hosted on the Raspberry Pi, whereas Klipper, the firmware, is on the main board. So a little fun fact, Klipper was actually named after the mid-19th century vessel, a clipper, which was built primarily for speed. It's a merchant ship. And this was created by Kevin O'Connor. It's made Klipper. And the other modules followed in suit with the Mare naming. So a Moonraker built by Eric Callahan is a light sail flown at the top of the mast, usually used on ships built for speed, or a Klipper. And mainsail done by Stefan Dej, and it's of course the principal sail of the ship. So kind of where the namings come from, if anyone was curious. So this is a part of Klipper that's really powerful. It's the macros and command tip links that you can do. So I think a lot of us are familiar with simple macros in firmware, sequential line by line, what typically you'd see in a G-code file. And we'll go over some of that, but what Klipper allows you to do is use the Jinja 2 template language and actually start introducing programming concepts into this. So, you can use variables, expressions, conditionals, loops, and objects. And what I'm really excited to show everyone is using shell commands. So shell commands are very powerful in Klipper, and they allow you to execute Linux commands and scripts pretty much directly from Klipper. And so to the right is a pretty example of a complex macro that's used for cleaning a nozzle. We won't get quite this complicated, but it kind of shows, kind of the level you can get to. And so that being said, I'll go ahead and switch the screen to our demo platform. Okay. So this probably looks familiar to a lot of people, and let me know if text is too small or anything. I can probably zoom in a little bit more, but if everyone's good with this, then we can go ahead. But so to the left here, we have our dashboard, right? And so when we want to add a macro, if you're using the Re3D Klipper stack, then we have a dedicated file for creating macros called the macros CFG. So that is going to be in the machine tab here, the wrench icon. And then in the files, there's a macros.cfg. So in yours, if you haven't, written any macros, this will be blank, but I've gone ahead and written some examples just to show y'all today. So our macro format is set up like this. We have a G-code macro tag, right? And then the name of our macro. This does not have to be uppercase. That's just the convention that I use. It could be lowercase. But so after you have this tag, you must have a G-code under here. And then each line after that, indented, will have the G-code. Now, this is running on a test bench right now, so it's not an actual running machine. So this is sandbox. So instead of actually running the G code, I'm running a M118. So what that will do is print it in the console here, so that we can see the logic and the functionality without actually moving anything. And so right now, this G-code macro move sequence is not added anywhere on the dashboard. So after writing something, we can save and restart. That will load it into the firmware. Once we reload, we can go up to our settings and go down to macros. These are all of our macro groups we've added. We can add another group, and this would add essentially a different panel. And then you can actually add each macro. So since we already have a panel, we're going to go to Extruder. We'll edit this. And then we have all the macros already in here, but we're looking for move sequence. So alphabetical order, go to move sequence. We've added that. So now we can exit this. I will go back to macro CFG. Okay, and so now that we have this macro, it's here as a button. And so we can click this button, right? And it will print out what we want to do, right? Home all, move to these coordinates, etc. Right? So we can have a button, but not only that, we can actually type it out into this console. And we can do it that way, or we can actually put it into a G-code file, right? So G-code files will actually interpret these as well. And there we go. So this would run the exact same thing. And so that way you can put things in slicers, right? And post-process, whatever you need to do. And so that's an example of, the most simple form of macro that you can do, just a sequence of G code. And so moving on to, some Klipper specific things. So one that I want to introduce is that Klippers can actually subscribe to objects, right? So there is such thing as like a printer object. So for example, printer.extruder.temperature will look at the extruder temperature and read that, whereas the target can read the target temperature, and so on and so forth. There's a lot of different statuses that you can check on and use in your logic for this. So basically, this G-code temp read will read out our metering zone temperature, and then also our target temperature, right? So we're at 23 and 0. And so we can see now metering zone temperature 23 and 0. So that's pretty cool that you can use that, reference different objects and different statuses in your macros. And you'll see that that will be pretty useful later on. And so moving on, we can use conditionals in our macros. So this macro kind of shows two different things that we can use. So first, we're setting a variable here. So we're setting input as a variable, but the input is actually a parameter. So with this params tag, we can actually accept a parameter into a macro. And so here, what we're saying is default is going to be 5 if we just click it. It's going to give a default value 5, and we're given the data type, which in this case is an integer, a whole number. And so moving on from that, if our input is greater than 4, then we're going to respond with a success message. But if it's 4 or less, right, anything else, then we're going to have a fail message, right? So our input is 5, right? We send that, we do get a success message. Whereas if our input is 3, for example, we will get a fail. So just trying to show the theory here, but down below here's an actual kind of applicable use case, putting some of the things together. So we're setting variables here with our metering, transition, and feed zone. What we're trying to check is our printer extruder, extruder 1, and extruder 2 targets. So this macro prepare pet G, it could be for, if you want to preheat, a little bit more complicated than just sending, of course, these commands. But you have some better checks and you can save some time with it. So we're referencing the targets here. I've set them to variables just so that I don't have to type this out in every single section. And so with our conditional statement, if the metering zone does not equal 220, and so if you wanted to check if it was equal to, we would do equal. But we're using exclamation, just that's the syntax for it. We're not equal to 220, and transition zone is not equal to 210, and feed zone is not equal to 190, then we will set the temps to that. Else, we're going to skip that and just print out heaters are at the correct temperature. And then we will end our if statement for this and carry on to our next one. So instead of just putting a G28, what if our machine is already homed? It doesn't make sense that we would have to do the whole homing process again. And so we can actually check if XYZ are in this object toolhead.homed axes, right? So if X, Y, and Z are not homed, then we are going to home. If they already home, then we will skip that. So when we run this now, parapet G, we'll see because the target temps were not set to that. We'll go ahead and set the temperatures. Printer was, of course, not homed, so we'll home. So moving on to loops. For those that don't know what a loop is, we can actually iterate through a set of commands multiple times, right, at a set rate. And you can even use that set rate to increment. And so in its most simplest form, we set a count variable to 10. For I, this is just any variable in the range of count. So in the range of 10, we're going to print out I and then just delay a second. And so this loop will essentially count from 0 to 9 each second. And it doesn't count to 10 because in programming, we always start from 0. And so this is 10 numbers, but we'll end at 9. And so something that this could be used for is, a simpler nozzle wipe procedure. All right, instead of typing out a lot of different coordinates, you could iterate those coordinates yourself. So here we have a wipe count of 4 for the count and range of the wipe count. We're going to go G1, X10, and we're putting in this in relative so that we'll go 10 and minus 10, and we'll dwell just a little bit in between just to kind of simulate the actual movement. And so what this will do is iterate through. So instead of having to type this all out in a macro, you can just set a variable count. So we can set that to 6 now. If we want to increase our nozzle wipe count. And now we'll iterate even more. Okay. So here's an example of extruder rotation. So there have been requests, and a lot of people do like to experiment with GBX in terms of revolutions and RPM instead of a filament distance. A lot of firmwares aren't very friendly to FGF. And so we're, developing more methods to try to convert these firmwares and these slicers into more accessible to FGF users. So this macro here will essentially take in input, right? However many revolutions you want to go. And then your RPM. So we're taking in these parameters, calling this a float and this an integer. And so we're setting this rotation distance to actually the rotation distance that we have in our firmware configuration. So just how we talked about objects, we can actually grab from our configuration files as well. So in this case, I believe our rotation distance is 3.846. And so to be able to get one revolution or however many revolutions, we need to multiply the revolutions by the rotation distance. And so in macros, we can actually evaluate at runtime here. So we can do operations like multiply. So you can see we have a G1E command here, and we will multiply revolutions by our rotation distance. And then our speed is RPM times rotation distance times 60 so that you get per minute. And so running that as a default value of 1 revolution, 10 RPM, we send that and we can see that we spit out a G1E 3.846 command in 2307. So if we wanted to go 2 revolutions or 20 RPM, for example, send that and we'll see that reflected there. Okay, moving on to shell commands. So shell commands are really useful when you want something automated, as well as if you want, any interaction with Linux and the logic that you can do there, as well as drip feeding G-code, because G-code is sequential. So if you have a macro that has a lot of G-code and you call that macro, then it will hang on that macro and not execute the next part until that's done. Whereas shell commands, we can essentially input our G-code into the queue while keeping that script running. And so as a very simple example, we have G-code shell command tag that we have to have. We're just going to call it run script. And what this command is doing is running Python homePy hello world.py. So if we go to our console here, we have a hello world script. And basically what this script does is just print out, a list of text, right? And so what we can do here is if I run that same command, we will get this output here. But if I run it through Klipper, then we can see that you get the same exact output on the side. So we are directly interacting with the command line here. And so that's pretty useful. We'll go into kind of that drip feeding a little bit next with requests. So the way that Moonraker works is that you make requests to it. And so there's 2 main types of requests. There's GET requests and there's POST requests. So GET requests are getting data, asking for information, whereas a POST request is sending data and asking for a command to take place. So I can show you an example of a GET request. So we can actually do this right in the URL. So what we're going to do is run printer objects query, and we're going to query the extruder. So the extruder, we get all of this data, right? Temperature, 24 degrees. And this is actually how Mainsail works. So Mainsail gets this information from Moonraker, and that's how it's able to display this information. So we do have extruder, but we can do all sorts of objects. We can do toolhead, for example, and we can see our positioning, our speed settings, all sorts. So this in its simplicity is GET requests. And so post request, you cannot do through URL. So we'll actually have to run this through a script. We have another Python script. In this, basically, we're just importing the request library and doing request.post, our URL, which is localhost in this sense because it is on the Pi. Otherwise, it would be a different IP address. And we're going to just post another M118 post request successful. So what we'll do is we can run this directly. If we run this directly, you'll see that we actually get the output on Klipper as well. So that post request is being sent successfully, but we can also turn this into a button. And when we run this, we get the same thing. And so we can put a lot of logic into this, and while a G code is running, we can essentially insert other G codes while that G code's running and make it not so sequential anymore, and more so insertion ready. So going back to our list. Let's see. So that's a little bit about post requests. So the next example that we have is about Arduinos. So we do have the ability to interface with an Arduino. I know a lot of people do like the test bench components with Arduinos, and it could be very useful to have that integrated into Klipper, especially for use cases where you don't necessarily want something just duty cycled, you want complete control over it. And so this was just a couple of steps here, but currently I do have an Arduino Uno hooked up to the test bench, plugged into the Raspberry Pi. We had a simple sketch of Arduino code. So this pretty much just starts a serial console, right? We have a built-in LED, and in that serial console, if we get a 1, then we're going to turn the LED on. If we get a 0, then we're going to turn the LED off, right? Very simple Arduino script that's loaded on. Now on the Pi side, we have another simple Python script that has the serial library in it. We're connecting to the same baud rate, and we see that the Pi is connected with this path, and we're pretty much just going to, pass in a parameter 1 or 0 with this Python script. And so you can see here we have 2 different G-code shell commands. This Python, it sends the 1 parameter and Arduino on with 1 and Arduino off with 0. And so running that, we should get, right, we have output that should say LED off and LED on. That is nowhere on the Pi script. So that's directly from the Arduino, and we can go ahead and click Arduino on. And we can see we did get a response, LED on and Arduino off. And the LED is now off. So this could be used for all sorts. This is just a simple example showing how you could initially get connected to an Arduino and start running these commands. So putting all of this together, here's kind of a more comprehensive macro, and this could be an example, start G code. So we are going to have a input parameter. So this is going to be the material that we want to use. The default is going to be PETG, and we're using the data type string. And so if material is PETG, we're going to actually call the other macro that we wrote earlier, prepare PETG. And so you can nest macros and call macros within each other. So that can make it easy to module out for more complex macros. Otherwise, this would be much longer, but with our conditionals, we can also use an elif. So else if material is PLA, and we can keep putting as many elifs as we want. But if it's PLA, then we'll just heat this up because we don't have a prepare PLA macro here. Else, we're going to say that it's an invalid material type and raise an error. And then we will go through, and for dramatic pauses, I have some dwells in here. We'll turn the Arduino on. We'll purge some material using our extruder rotation. We'll wipe the nozzle, and then finally we'll turn Arduino off. And so running this, we'll run it with PETG. It will start outputting everything from most of these macros. We homed, heated up, LED on, purged our material. We're about to wipe the nozzle. And finally, we will turn the Arduino off, and we're finished. Okay. So that was a pretty quick run through of some of the simple things that we can do with Klipper. I hope that this was not too fast and too comprehensive. I want everybody to definitely, hopefully be inspired and try to use this to automate their own projects. But I think that's all we have left for the demo, but I do have some more to show as far as some of the implementation cases we've used. So I will go back to our slide deck. Okay, so one thing that I have been working on and is print recovery. So print recovery is not natively built into Klipper. And so I've been trying to tackle some ways to do this. And so, I thought that Moonraker would be a perfect example to go with because we're able to get a lot of data from Moonraker that isn't necessarily displayed through the UI. And so going to this endpoint on Moonraker, you can see the printer IP objects, and we query the virtual SD card. While printing, we can see this is active. We can see progress and file position, file size. And so I didn't want to just, resume the print at the last layer that it was at. I wanted to resume it on, the last line at the exact spot. And so this allows us to do that. And so our file position is, this is by byte, right? And file size is by byte as well. So at any time we can query Moonraker and see exactly the position of the file that we're at. And so we can keep a spot there and a note so that we know where we left off if anything were to happen. And so this there's a Python script that's called at the beginning of the print that is constantly monitoring this file position. And it subscribes to that print status. And if the print is interrupted anyway, then a copy of the original G-code file is made, and that file is parsed, looking for the last Z height so that you can raise to that Z height, as well as the start G code and position of the tool head. So if anybody is interested, I've linked the repository here to experiment with it. It's not quite ready for production, but if you're willing to experiment with it, then yeah, please feel free. So this autoloader project was actually worked on by one of our other engineers, Eric Gohl. So he's one of our hardware engineers, and this is a pneumatic material feed system. He can definitely tell you more about the hardware. Definitely more concerned about the logic of this. But the way that it works is that there's a capacitive sensor on the extruder or on the feed, and you can use a shell command to run Python logic, right? And you can provide parameters like start delay, overfill delay, and timeout for how long after it hits the sensor or if it doesn't trigger as a safety mechanism. And this logic script, it subscribes to the material sensor through Moonraker, and then a post request is sent to switch on a relay to the pneumatic system and the valve to turn it on and turn it off. And so that way you have pretty much complete control over it through Klipper. No need to have to go to the command line or manually start an Arduino, or otherwise we can duty cycle it ourselves. And one last thing, it's not necessarily built within Klipper. It's built a little outside. This is a project I've been working on for quite some time now. I've called it Helm. It's a fleet monitoring and control application. So it's a web application just like Mainsail, but it's meant for multiple printers. I had this idea when working here. We always constantly have a lot of printers running, and without actually doing a manual scan of the network or going up to each printer, since we use DHCP, they change IP addresses constantly. And so I wanted a way to automatically look for just printers on the network and to have that in one place, so I could see and connect. And it's transformed into a fully fledged web application while I've worked on it. And so once we do automatically scan the network, we pretty much ask, are you a Klipper printer? If you are, we're going to add you to a list. You're going to get a panel, and then we will subscribe to all sorts of information with Moonraker. And with that, we can also select multiple printers and send post requests. So again, we're using Git and post requests for all of this functionality. So it's not necessarily using Klipper, but it is using Moonraker to talk to Klipper and get information from it. Yeah. Here's some useful links. I didn't put everything here, but as far as Klipper official documentation goes, a lot of documentation on the printer statuses, the objects, as well as like macro syntax. Moonraker has great documentation about the Git and post requests, and Mainsail has some other little guides about macros and some other things I didn't cover, like prompts and different features that are specific to Mainsail. And again, this is our Re3D GitHub. So that's where we host our Klipper stack. So feel free to take a look at that. But yeah, that's all I have. Thank you.
It was outstanding, Mitchell. Does anyone have any questions for Mitchell while we have the recording still on? I personally liked the history on Klipper and Mainsail and Moonraker. I wasn't aware of that. That was super neat.
Yeah, it's pretty cool. Yeah, so I don't know if you caught it, but that's one of the reasons I call it the application helm, is because of a ship, right? The helm of a ship. Just continuing with the mariner naming.
That's really witty. With that in mind, we'll go ahead and we can pause the recording in case anyone would like to chat offline. Again, same bat place, same bat channel next month. If you're interested in presenting, regardless if you have a gigabyte or a part of the Re3D community, you're welcome to share. Hopefully we can live and grow together. But we'll go ahead and turn the recording off.